Hello everyone and welcome to our second Haloacetic acids coffee conversation on the topic of current regulations for the analysis of these compounds. Joining me again today we have my colleague Gemma Ellison, who is an ion chromatography specialist. Hi Gemma, how are you today?
I'm very good, thank you, Simon.
Oh, great to hear that, Gemma. So let's get started with today's conversation then. In our last conversation you introduced us to what haloacetic acids are, how they are formed during the water disinfection processes, and why it's important to measure them. My first question today is, what is the current situation with respect to haloacetic acid analysis legislation, beginning with the United States, and what changes are coming?
Okay, so as we briefly mentioned in our last chat, the regulations that are in place now, they do vary for different disinfection byproducts, DBPs, and they even vary on which haloacetic acids are specified, so this depends on where you live in the world. And we'll talk about the changes later because these are related to Europe, but currently in the United States, the Environmental Protection Agency, the EPA, regulate the HAA5. So do you remember that lineup from last time we spoke? You'll recall that the HAA5 include dibromo, dichloro, monobromo, monochloro, and trichloroacetic acids.
I remember all those three-letter acronyms associated with them.
That's the ones. So the US EPA has two analytical methods for regulating the HAA5, and they have really led the way in regulating haloacetic acids, and most other countries have followed their lead to different extents. So the US EPA, they've also been running an unregulated monitoring programme, and the latest version of this is the fourth Unregulated Contaminant Monitoring Rule, UCMR. And this stems from the 1996 Safe Drinking Water Act. What happens is once every 5 years, the US EPA will issue a new list of no more than 30 unregulated contaminants to be monitored by all the public water agencies. And this fourth one was published in December 2016. And this was for additional monitoring between 2018 and 2020 using the analytical methods developed by the EPA and all the consensus organisations. And included in this were the HAA6 and HAA9, as well as the regulated HAA5s. And this was to further understand the prevalence and the co-occurrence of all of these disinfection byproducts. As well as that, there were some additional indicators. So they looked for total organic carbon and bromide in the samples that were collected for HAA analysis. And these were also analysed using approved US EPA methods. And again, this was to study the relationship between the occurrence of the different disinfection byproducts. And this monitoring, it really provides a basis for future actions to protect public health, essentially.
Okay, thanks Gemma. So what are the actual regulatory limits for the US? And what about the rest of the world? What legislation is in place, say, for the Far East or for Europe?
Okay, so the EPA has the EPA 552. There is 552.1.2 and 0.3, which all vary slightly, and EPA 557 methods. And these are currently regulated at total level of the HAA5s of 60 micrograms per litre, as you can see from this table. The regulations around the world do currently vary considerably. So, for example, in Japan, they only regulate and monitor 3 HAAs, and China only regulates 2 of them. And they have individual maximum concentration limits as opposed to a limit of all of them together. So in Europe, the European Union Commission only currently regulates DBPs, which are trihalomethanes and bromate. So these are described in the Drinking Water Directive 98/83 EC. But this document was reviewed in December 2020, and there's a number of interesting reasons why this review took place, and some of them are a little bit revolutionary. So the reasons for this review were the current regulations were over 20 years old. So the review was to determine whether those regulations still stood today with, on reflection of emerging pressures, and to ensure the future quality of water for people living in and visiting the EU. And then there was also this increased pressure from the European Citizens Initiative called Right to Water. And this was a real kind of power to the people movement. This was just ordinary people who collected 1.8 million signatures for their petition. And this was to ensure that everyone benefits from clean water and sanitation. What their campaign actually stated was that there are still approximately 2 million people in Europe that do not have suitable water and sanitation. And also a number of low-income households that were threatened with suspension of their services because they couldn't afford to pay their water bills. And then there was a third reason, and this was to ensure like a consistent quality of drinking water available to everybody, to reduce the reliance on bottled water. So this was in a bid to reduce plastic consumption, which we know has other environmental effects on our planet. So included in this revision were our friends, the HAAs, as well as some other DBPs, so chlorate and chlorite, and then also the inclusion of PFAS compounds. So PFAS is a whole other topic in itself, and I think we'll need to do another coffee conversation series to cover that. So with this, yeah, it's a big topic. So with this changes, it's important to note, so this is the EU directive, and this now no longer includes the UK. And although monitoring is required in the UK to keep HAAs as low as possible, which is what's stated, the regulation change, it won't take effect in the UK yet. So we'll have to see what happens there. So the changes are coming, and water testing labs need to be prepared to meet the new regulations. And the revised Drinking Water Directive states that the HAA 5 should have a maximum concentration limit of 60 micrograms per litre. So it very much reflects the EPA limits.
Okay, that was a really detailed explanation about the regulatory landscape for HAAs. So thanks for taking the time to go through it with us today, Gemma. It was brilliant. So join me and Gemma again soon for our third HAA coffee conversation, in which we'll discuss the approved methods and techniques that can be used for haloacetic acid analysis. So for now, bye everyone.
Thank you, bye-bye.